Hello, this is section Math 25, section 1.4 on quadratic inequalities. So objectives finding x-intercept for the quadratic functions and solving the quadratic inequality. Okay, so we are using the quadratic inequality, so we are using the quadratic function to find the answer for inequality. So solving the quadratic inequality while the graphing the quadratic function, the most important point was the vertex. The vast majority of the question from the section 1.3 were directed to find the vertex. So when solving the quadratic inequality, the vertex takes a significantly less important this time. We will learn the x-intercept more critical this time. So recall from the lines, the x-intercept were found by the letting f of x equal to 0 or y equal to 0, and then solve for x. So graphically speaking, the any all points on the axis will always be in the form. And then consider the following the three quadratic function we have here. Okay, so f of x and g of x and then h of x. Okay, so let's find the x-intercept for each of the functions. Okay, so in order to find the x-intercept, you need to set the f of x equal to 0 because y is always for the x-intercept. Okay, x-intercept I told you that is a n 0, right? So y is always 0. And then good thing is this is factorable. So it's a factor as x plus 3 times x minus 1. And then set each factor equal to 0. And then you'll find the two solution for the x. Subtract 3, so negative 3, x equal to 1. So these are the x-intercept as a solution. We are just solving for the equation right now, okay? Instead of the inequality, okay? Let's go to the next questions. The g of x equal to negative x plus 1 square, same thing. So set the g of x equal to 0 of negative x plus 1 square. And divide by negative 1 both sides, still 0. You got the x plus 1 square. And then you need to put the square root on both sides, which is square root of 0 is a 0. But of course it's plus minus, but 0 is a 0. Okay. And then you get the x plus 1 comes out. And subtract 1 both sides. X equal to negative 1. So that's the x-intercept solutions, okay? And then the third one, z equal to 0, x squared minus 2x plus 5. But bad thing is, it's not factorable. So in order to find the solution, we have a quadratic formula, which is x equal to negative b plus minus b squared minus 4ac over 2a, which is negative of negative 2 plus minus negative 2 squared minus 4 times a times c over 2 times 1. And simplify, you get 2 plus minus 4 minus 20 over 2, which is 2 plus minus negative 16 over 2, which is 2 plus minus 4i over 2, and then reduced by 2, 1 plus minus 2i. Which means this is the solution, but your solution is imaginary, right? So this is actually the no x-intercept because the x-intercepts are always real. So this time there's no x-intercept. Okay, since every parabola turns only once, every quadratic can have a 2 or 1 or a 0 intercept. So if you go back to the first example as a 2 x-intercept, right? Second one is 1 x-intercept. And the third one is no x-intercept at all, okay? So that's the case. So when you're graphing the first one, x-intercept is negative 3 and 1, right? Okay. So using the graph, we can answer the several questions about the function involving the inequality. So inequality could be the greater than 0, greater equal to 0, less than 0, or less than or equal to 0. So for the solving, the x squared plus 2x minus 3 greater than 0, which is we got the graph. But greater than 0 means, okay, this whole thing was a y, isn't it? So which means y should be greater than 0, okay? So as you notice, what is a y is greater than 0? Greater than 0 means y is greater than 0 right here, this place. So what parts of the graph of the parabola is above the 0? So right here, isn't it? This one to this one, right? But answer is about the x values, right? So from where to where? From this place. Okay? So all the way from the negative infinity up to negative 3. But negative 3 is not included because there's no equal sign. And then starting from the 1 and then to the infinity, okay? So which is a negative infinity to up to negative 3, then 1 to go to infinity. For the second one, is difference is equal to. There's equal to, so you also need to include the negative 3 and 1, right? So all the place of the above the 0 is a parabola is here to here. So that's why you got negative infinity to negative 3 and then 1 to infinity. And two sets of the interval you need to connect with the union as a u. Now x squared plus 2x minus 3 less than 0. So this time is y should be less than 0, which is less than, y is less than 0 is from this place, right? So what parts of the parabola is less than 0? Is from here to here, isn't it? Here to here. So up to where? Up to this place to this place, okay? So negative 3 to 1. But there's no equal sign, so you're not supposed to include that as a negative 3 and 1. But less than equal to 0, of course, this place is less than 0, so x value should be negative 3 to 1 as a close, which is a bracket. So all four inequality questions can be solved by knowing where the graph crosses the x-axis in the direction of the parabola. So f of x greater than 0, which means function is a positive, it's above the x-axis, and intercept is not included, but there's an equal sign, so it's included. Less than 0 is a function negative below the x-axis, but not included as x-intercept. And the less than equal to 0 is a negative, and below the 0 but included because equal sign. So there's a difference between the equal sign or no equal sign, okay? The important idea to remember is that the greater 0 or greater equal to 0 means that the graph is above x-axis with the greater equal to 0, including the x-axis intercept, okay? So likewise, the less than 0 or less than equal to 0 means the graph is below the x-axis with the less than equal to 0 include the x-intercept. So one important detail to remember that the analysis only works when the comparing to the 0. So the outline of the process for solving quadratic inequality can be described as follows. So compare the quadratic function to find the x-intercept, draw the sketch of the graph, and state the answers. Okay, so let's do the first problem. So first of all, I need to subtract for both sides to get the quadratic standard form. But I need to find the solution for x in quadratic, so I'm just using the equation, okay? And then I think it's a factorable. Because if you put the 3x x, and then there's a 12 has a 4 and 3. So if I put the negative 4 here and plus 1 in here, and the negative 4 plus 3 is going to be negative 1. Yeah. So you got 3x minus 4 equal to 0. X plus 1 equal to 0. So one solution is 4/3. Other solution is negative 1. So 4/3 is like 1 and 1/3, isn't it? So 1 and 1/3 about here. And then negative 1 is right here, okay? And then a is a 3, which is a positive, so it's going up. And then we don't really need a vertex, but of course you can find the vertex too, but you know. So graph is going to be something like this. Okay, that's important. But now you have to check the inequality. It's a less than equal to 0, right? So what parts of the parabola is less than or equal to 0? This place. Yeah, this place. So what value of x? This is it. So from where? From the negative 1, 2, and 4/3. So that's the solutions. Let's look at another one. Solving negative x plus 1 squared less than 0 here, okay? So this time, x-intercept, right? Yeah, x-intercept is most important this time, okay? So x-intercept means what? Negative of x plus 1 squared set equal to 0. Divide by negative 1 both sides, which is x plus 1 squared equal to 0. Square root both sides, but 0 doesn't matter of the sign. So x equal to negative 1. So x-intercept is negative 1 right here. And then the a is actually the negative 1 this time, which is less than 0. It's going down. But this is also the vertex too. which is from here, yeah, your graph is going to be this. Something like this, okay? But we're looking for the less than 0, isn't it? Less than 0, but not equal to. So less than 0 means where's the less than 0? This is a less than 0, and this part is a less than 0. So from here, all the way to here, all the way to here, but except the negative 1 place. So you gotta say that the negative infinity 2 up to negative 1, and then negative 1 to infinity everywhere, and then put the union set. All right, the last one. The last one we have here, okay? So last one we have is and same thing. We're just gonna set equal to 0. So x squared minus 2x plus 5 equal to 0. And so for x, so this is not vectorable, so negative b plus my quadratic formula, b squared minus 4ac over 2a negative of negative 2 plus minus b squared negative 2 squared minus 4 times a times c over 2 times 1, so 2 plus minus 4 minus 20 over 2, 2 plus minus negative 16 over 2, which is not a real number. So which means this is the means no x in a set because of negative 6. Negative can be in the square root, okay? So there's no x in a set, so what should I do here? This time I think we better have a vertex, okay? So for the graphing, right? So vertex is, which means h is negative b over 2a, so negative of negative 2 over 2 times 1, which is 1. And then plug it in, find the k, plug it in h of 1, so 1 squared minus 2 times 1 plus 5, negative 1, 4, isn't it? 4, right? So vertex is 1 and 4. So from 1 and 4, and then it goes up. Yeah, you got this kind of graph. Which means we're looking for the less than equal to 0, right? The less than equal to 0 means what? You have to have a parabola should be under here, but I don't see any parabola. So this is going to be, you got to say that there are no solutions. Okay. But what if this is greater equal to 0, which means all real numbers, okay? All right. I think that's all. Thank you for listening.